Okay, so we're going to be graphing this data where the photosynthetic photon flux density is going to be your x-axis. It's called the independent variable. And the net leaf photosynthesis is going to be the y-axis, which is the dependent variable. And here we have actually used a line graph because we have way too many data for a bar graph, because we have to plot essentially 3, 6, 9, 12, 15, 18, 21 data points. That has to be a line graph. Okay, so let's go ahead and figure out the scaling on the x-axis from 0 to 1500. That means that each tick here has to be 100. So 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1100, 1200, 1300, 1400, 1500. Good, we covered 2/3 of the graph, we're perfect. Of course, you must label your x-axis with photosynthetic photon flux density with the unit. And for the y-axis, you must label it as net leaf photosynthesis. Net leaf photosynthesis. Of course, with the unit, which is mu mol CO2. So mu mol CO2 per meter squared per second. How about the scaling on the y-axis? We have to go from as low as 0 to as high as 16. That means I'll be making each tick as 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Perfect. And now it's time to graph. We also have to use what we call a color code because we have to represent the shrubs growing in full sun with one code. Let's say I'll be using an empty circle. We must represent the shrubs growing in partial sun with, let's say, a triangle. And let's say I'll be representing the shrubs growing in shade with a square. And now it's time to actually graph. So let's just look at the data again one more time. So look, when the density is 0, which is on the x-axis, so 0, let's start with the circles, which is the basically the shrubs growing in full sun. We also have 0. So I'll be doing 0 and 0 with a circle. Then I'll be doing 50 and 2.3. So 50 is here and 2.3 would be here. Another circle. 104.5. So that's 100 and that's 4.5. Wait, I made a mistake with this one. It has to be here. 104.5, which is here. Then we're going to have 207.5. 207.5 is here because that's 7 and that's 5. Okay, 511.7. So 511.7 is here. That will be all the way here. 1014.8. So 1014.8 is here. 1516. So 1516. Now, of course, you will connect each adjacent circle, two adjacent circles with a line. So we're going to have line 1, line 2, 3, 4, 5, and 6. Okay, we took care of the circles. Now it's time to take care of the triangles. So, when it's 0, it is also 0. Now you must now draw a triangle here. I know it's going to be confusing, but that's the whole point, that you know what you're doing, right? So it's okay. They know you're overlapping triangle in a circle. It's okay. 50 and 1.8. So 50 and 1.8. So this would be here. 50 and 1.8 would be here, essentially. 104.7. 104.7 would be also here. Okay. 207. So 207, which is here. Let me fix the triangle. Okay. 509.6. 509.6. So 7. Let's see. 8. 9.6 will be here. So 509.6, which is here. Okay, 1,011.1. So 1,011.1. 1,011.1. So that'll be here. So a triangle right here. Now we're gonna have 1,511.6. 1,511.6. That would be here. And now connect them all with lines. So 1, 2, 3, 4. Okay. This and that. Now finally we have the square. So now we're going to do 0 and 0.5. So that would be definitely here. Now we're going to do 50 and 1.9. 50 and 1.9. It's very messy now, but it's okay. Now we're going to do 100 and a 2. So 100 and a 2. Then we're going to do 202. Then we're going to do 502.9. So 502.9 would be here. 1,003.2. 0.2 will be here. 1,003.2. 1,504. 1,504. That'll be here. Now connect them by a line. So 1, 2, 3, 4, 5, and 6. And that's it. You have your diagram.